If we did 8, let's take it one step further just for the sake of what I'm dealing with now. What would be the average velocity now? Sorry?
It would be the same
No.
because you would
0. Average velocity now is 0. This is a little bit beyond the problem, but I'm getting to a point for this. So, there's nothing special about every 1 second if acceleration is constant. We could do every other second, so I could just get rid of these. We can add those up and divide by 5. We get the same answer. But there's nothing really special about every 2 seconds. Why not every 4 seconds? We can add those up and divide by 3. Matter of fact, there's nothing really special about every 4 seconds. Why not every 8 seconds? We can just add those up and divide by 2. And as a matter of fact, I can find the average velocity just by averaging the first and last numbers. So in our back to the problem, so it's v initial plus v final divided by 2. So that's 20 plus negative 15, as stated in the problem, which is 5 divided by 2, or 2.5 meters per second. Now, this is the fastest way of doing it. Again, acceleration is constant, is assumed. Just add the first and the last one. I did one of them where, I think it was like 40 seconds, over 40 seconds. Somebody wrote up a chart starting from 0 all the way to 40, and then they added up the 41 numbers, divided by 41. And yes, it's completely legitimate, or you could just take the first and the last one and average those 2 numbers. The most common mistake I see is people adding these together and then dividing by time, which actually has no physical meaning. All right, questions to here? Displacement. Before we hit displacement, suppose you drove an average of 50 miles per hour for 3 hours. 50 miles per hour on average for 3 hours. How far did you go? Yeah. Same thing's going on here. I know what my average velocity is, and that's my average over 7 seconds. So to find my displacement, just multiply it. My average velocity times time. So that's 2.5 times 7. 17.5?
17.5.
Okay. Units?
Meters.
Yeah. Ashland?
Yeah, so that was the change in the displacement, right? Or the displacement?
That was the displacement.
So for that one, can you multiply, is it just multiplying the velocity average or the velocity itself?
Velocity average.
Okay.
Now, there's a video where I go into a more complex formula, and for those who are, and occasionally some students latch onto that and they find that just a lot easier, and more power to you. But there is a video where I do it slightly differently, combining 2 different things Hewitt does. Hewitt doesn't actually combine them, but when he does combine them. All right, so if the car starts out at 20 meters per second and ends up at negative 15 meters per second, what do we know happened? What did the car do to go from positive velocity to negative velocity?
Went the other way.
Sorry?
Went the other way.
Okay, it does end up going the other way. So what does it have to do in order to go the other way? Okay, it's a one-dimensional problem. So not a big arc. That would completely change what we're doing here.
But just like went back.
And as was written up here, at 4 seconds, it's at 0. So if I sort of sketch it out, we've got positive direction here. Car starts out, it comes out to here, turns around, and then ends up Well, it ends up 17.5 meters positive. So that's my starting point, and it ends up at 17.5 meters. That is absolutely horrible. It ends up 17.5 meters on the plus side of where I started. So this next one is, what is the distance? In other words, how far did I actually travel? So what I really need to do is figure out how far to here. How far am I going to the right before I turn around?
Wait, real quick, I have a question. So you said the car doesn't turn around?
It moves in one direction and then moves in the other direction.
So-
It's like you're going up a hill with your brakes off, it just reaches a stopping point and then starts coasting backwards.
Okay.
Yeah, the comment was in relation to what Elizabeth Ann did, where she did this big sweeping circle like you're going around a curve. We're not going around a curve. There are a number of problems where I do this. There's some videos where I talk about this. I'm gonna zip through this a little bit quickly because there's something else that I want to get done. But I know at this point right here, so at this point it's going 20 meters per second. At this point going 0 meters per second. That's the turnaround point. This is 0 seconds, and this is at 4 seconds. For this region right here, what is my average velocity from start to stop?
Maybe 10?
Yes, my average velocity is 10 meters per second. That is my average over 4 seconds. So how far did I travel to the right? I think there was some discussion over there.
40 meters?
Yeah, 40 meters. So this is 40 meters here. So I go 40 meters to the right, and then I go to the left, and I end up 17.5 meters from where I started. So how far did I move to the left?
So you subtract?
Say it again?
You subtract?
Yes. Which is 20.5.
22.5.
So I went 40 meters to the right, 22.5 meters back. How far did I actually travel?
62.5 meters?
Yep. So my distance, 62.5 meters. And so now I can answer the question of what's my average speed. That's just distance divided by time. So my average speed, not velocity, average speed is 62.5 divided by how much time? 7 seconds. Whatever, that's just shy of 9, 8 points. Eight. 8 point what?
8.9.
So you round it up?
8.9 meters per second. Now, I've done it, I talked about one of these things, I talked about something in the video, in the orientation videos, and I think it became very apparent, well, actually every class, my hearing is not great. And that faces people who don't have confidence in physics and speak softly. So please, just assume you're right and speak out boldly and loudly. And then when I say, no, that's not right, look at me with disdain because I'm beneath you.
Wait, so how did you get 8.9? Because I got 8.64.
It should be 62.5 divided by 7.
Oh, okay, I had it wrong. My bad.
Okay. And what's the lesson there?
Okay, I got it.
Sure you're right.
Yep, that's it.
What did he say?
Show your work.
Show your work.
Yeah, really frustrating. 110 worse than any of the other groups as a rule. Not this group. All the previous 110 classes of people not showing work. And then I'm going, because I love partial credit as a student. I like giving partial credit as an instructor. Right? It's very difficult to give partial credit for someone who shows absolutely no work.
Is it possible that you can scroll it down a bit because it's cut off at the bottom? Okay, thank you.
Can you run by like the distance thing just one more time?
All right. Did you get that, why this is 40 meters?
Kind of, like I got the average velocity, but how did you go from the 40 meters on that part
Right.
from the velocity?
So displacement is average velocity times time.
Okay.
In, I guess, middle school physical science or whenever you had it, it's the distance equals rate times time formula. So, on average, 10 meters per second. It took 4 seconds to stop. Times 4 seconds.
Okay,
That's where the 40 comes from.
got it.
You keep going?
Yeah, so would you take the remaining, the 3 seconds?
So the remaining 3 seconds, I can do it 2 different ways. Actually, there's several different ways. But to me, the simplest one is I know I end up 17.5 meters on the positive side of where I started. So therefore, since I ended up here, the distance I moved back is just the difference between 40 and 17.5.
Okay.
For those who love doing more math, I'm going 0 meters per second here, and I'm going negative 15 meters per second there. And this takes place over 3 seconds. My change in velocity is, or sorry, my average velocity on the trip back is negative 7.5 meters per second for 3 seconds. So if we multiply those together, you'd get 22.5.
And then you get rid of the negative because it's distance and it
Yes.
doesn't have a direction.
Absolutely.
And so the 17.5 is from your displacement?
Yes. So, like, yeah, I have videos on this, but I also have 6 additional problems. I think it's under supplemental materials. But I do have 6 additional problems. I do 3 where I don't give the displacement. Sorry. There's, I think 3 where I give the acceleration and 3 where I don't give the acceleration. So, in essence, there's basically 5 things that I could give you. If I give you 3 of them, you can figure out the other 2. Yes, Elizabeth Ann.
On your supplemental material link, it doesn't let you click it. It leads you to an error page. This
Oh,
link
wait,
right
I
there.
have the same problem. If you download the attached files at the top of Canvas, you can download it.
But isn't that something different?
Yeah, that's, all right, scroll up. And just click on something. But I need to click on that. And it would be, yep, there we go. Supplemental material, supplemental material Fox made, and then chapter 3, and then there's. Eight. And there's 8 problems there with solutions. All right. Now, building on the excitement, we're gonna head down to the other room and play with lab quests and discover things or confirm
Good choice,
things.
it's physics.
That's absolutely. Jennifer, Lexi. I think you two are gonna be the last 2 names that I commit. My worst case, I did have a course, I think it was my first year here, I had a student, end of the semester, not taking the student's name. I made it way too abundantly clear. Okay.